Now question 9, continuing with chapter 6.2, is a beautiful little question, so creative. Look at this. It says, pen, where are you? Yeah, it says an interior, that's that one, and exterior angle, that's that one, of a regular polygon are shown. Don't know what it is. We can't go counting the sides and imagining it all coming down here and us adding on some sides. No. Work out the number of sides of the polygon. Well, listen now. I've got a straight line. You should recall that the exterior angle there plus the interior angle will come up to 180 degrees, and there is anyway on a straight line. So let's just work out what x is, and then we'll talk about it. So I've got, yellow would be better, I think. I've got x, the exterior, plus 4 lots of x plus 15, the interior, come to 180 degrees. So multiplying out the bracket, I get 4x plus 60 comes to 180. Simplifying, 5x plus 60 is 180 degrees. Charming. So 5x is going to be 180, take away the 60. So 5 lots of x is going to be 120. Dividing by 5, I will get what x is going to be. And I think that's, let's have a look, 24 degrees, I believe. Check on the machine, because I'm not very confident. 120 divided by 5, yeah, 24. Of course it is. Now, great, so I know x is 24 degrees. Let's go put 24 down there. And the leftovers inside there, I don't really mind at all. Do you remember that if you take 360 degrees and divide by the number of sides, you will get the exterior angle? Let me just write the rule for you. So, exterior angle, the one on the outside, is going to be 360 degrees, and then divide by the number of sides on a polygon. Alright? Now you may recall therefore that all the exterior angles added together for any size polygon with an unlimited number of sides, whatever the number of sides are, you can work it all out and do 360 over a number of sides, will give you the outside angle, exterior angle. Sorry, that sounded really garbled, but what I'm trying to say is, if I rearrange this, I can say to myself, I've got 24 exterior angle equals 360 divided by, just call it n, swapsies, the number of sides is going to be 360 divided by my exterior angle of 24. I'm now going to pick up my calculator and go 360 divided by 24, and if you get a whole number, you've got it right. If you end up with a crazy number, you can't have a bit of a side. You either have 14 sides, 15 sides, 16 sides. You can't have 14.3 sides. So if you've got a whole number, you've probably got it right. This is a 15-sided shape. Don't know what it's called, but it's a polygon with 15 sides, and it's regular. Alright, that's question 9 done. Now question 12 claims to be grade B. Maybe it is, maybe it isn't, I don't know. But let's just do it. The diagram shows a rectangular garden, okay? Rectangle, it's 7 that way and 2x plus 3 meters that way. Right, part of the lawn has been removed to make space for a rectangular pond. Now the pond has dimensions x plus 1 multiplied by 4 meters, so it's a sizable pond. Now the area of the lawn is 35 meters. That's just the green bit. So I'm going to put here, I don't know if you can see that, but I'm going to write it anyway, meters squared. It's an area. Work out the area of the pond. I'm going to put a little question mark there for me. So essentially I need to set up an equation whereby the area of the entire garden, subtract from that the area of the pond, and that will equal 35, because it leaves me with the area of the lawn. Alright, so essentially big rectangle minus little rectangle equals 35. If you can say it like that, then just do the maths. So big rectangle, 7 times 2x plus 3, so it'll be 7 bracket 2x plus 3. Remember, this is forming equations using brackets, so it's likely to involve a bracket. So 7 by 2x plus 3. When I take away the dimensions of the little pond, so that's going to be 4 times x plus 1, will come to the grass, which is 35. Alright, so that's my equation, and that's not difficult. It's just extracting it from the information given is difficult, so I suppose you could call it grade B. Multiplying out. I'm not going to do arrows, it's a bit complicated. Just follow what I'm doing. Okay, simplifying. 21 take away 4 is going to be something like, I don't know, 17, isn't it? Equals 35. So 10x's, it's going to be 35 take away 17. 18, great. Gone glitchy, stop it. 18. So x is going to be 18 divided by 10, 1.8, and that'll be in meters. So work out the area of the pond. Alright then, so here's my pond area. Do it here. So I substitute 1.8 into the x, so it's going to be 4 times bracket 1.8 plus the extra 1 meter. Pick up my machine, that'll be 4 times 2.8, and that'll give me something. 4 times 2.8 is 12.2. No, I read it wrongly. 11.2, not 12. Yeah, there it is. 11.2 meters squares, and that's what I make that, and I'm sticking to it. That's question 12 done. What else we got? Question 14 is tricky, very tricky. Mathematically easy, but getting your head around what to do with the ratio is tricky. The areas of the two shapes are in the ratio of rectangle to triangle, 3 lots to 2 lots. So if I was to simplify this down, you won't like what I'm about to do, but if I simplify the ratio, this will be 1.5 to 1. In other words, it takes 1.5 rectangles. The rectangle is 1.5 times as big as the triangle, essentially. You happy with that? So the area of rectangle is 1.5 times as big as the triangle. So in order to make the areas equal, if I multiply the area of the triangle by 1.5, it will match the area of the triangle. Is that fair enough? Right, so okay, so area of a rectangle is 1.5 times as big as the triangle. So if I multiply the triangle by 1.5 times, I should get an equation set up, and that's the hard bit. So if I multiply this by 1.5, they're going to match exactly, aren't they? Alright? Or I can multiply by 3 over 2. Or multiply the rectangle area by 2 and the triangle by 3. That's another way of doing it. So let's just stick to this 1.5 thing. If it gets all difficult because there's too many decimals floating around, then I'll review it. But again, we've got a calculator. So let's just stick to having to boost this yellow triangle up to 1.5 times its area to make it equal to the rectangle. Alright, so if I stick to that, area of rectangle therefore is going to be 3 lots of 2x plus 6, and it's going to be equal to the triangle if I multiply it by 1.5. So it'll be 1.5 times, now the area of the triangle, half, times base, times height. Okay, so if I tie this horrible little thing up and multiply out, I've got 6x plus 18 comes to, now let's just do half of 4 is going to be 2x's. 2x times 5 is going to be, well, that's going to be 10x's, and multiply that by 1.5. Well, 1.5 times 10 of course is 15x's altogether. Right, let's just subtract my 6x's over there. So I've got 15x minus the 6x's will come to 18, positive 18, and that is going to be 9x's come to 18, and therefore x is 2. Now let me just test that we got it right. X is 2. Let's just substitute into here in working blue, shall we? So 2 times 2 is 4. 4 plus 6 is 10. That side is 10. And 3 times 10 is 30 centimetres. Yes, centimetres squared. Now if x is 2 again here, I've got 8. 8 times 5 is 40. Half x is half base times height. Comes to 20 centimetres squared. And look, the ratio 30 to 20, 3 to 2 is perfectly right. But it's tricky getting this little bit around your head, working the ratio of multiplying up this horrible triangle by 1.5 to make it equal to the area of the rectangle. Alright? Very tricky, I thought. Right, question 16, another one of these problem solving affairs. Right, it's got here, back to yellow area. It's got here, Jack is 47 years of age. So this is Jack, who is 47. And here's his son, and we should call him son. He is 19. Now, in how many years will Jack be twice the age of his son? Well, I don't know how many years we're talking about. But if I add X years onto Jack's age and X years onto the son's age, that's fair. Because if we're going to go up 5 years into the future, then they'll both be 5 years older. Now, the situation says, in how many years, in other words, work out the X bit, will Jack be twice the age of his son? So in other words, I take the son's age, multiply by 2, and that will come to Jack's age in how many years' time we're talking about. So there's the equation, alright? 47 and 19, add on the same amount of years, X, and at a certain value, X, the son will be half the age of the dad. So, or Jack will be twice as old as the son. So that's that. So here's our equation, therefore. Multiply out on the right hand side. I've got 38 plus 2 x's. Let's just take my x over there and subtract, and my 38 over here and subtract. So I've got 47 take away 38 is 2x minus x. So just doing this bit first. X equals 47 take away 38, 9. Therefore, in 9 years' time, and I didn't use a trial improvement, I set up a proper equation at this grade level and solved it. I wasn't guessing. So in 9 years' time, Jack will be twice as old as his son. Last question, I believe, in this section. Right, we've got Trevor and Andy out on a spending spree, or whatever they're doing. Right, Andy and Trevor start the evening out with £45 and £95 respectively. In other words, that's Andy and that's Trevor. Let's just write it down here. So Andy starts out with £45, Trev starts out with £49, okay? They both spend equal amounts. Now if you're spending money, you're going to end up with less than you started with, but they're spending equal amounts. So I'm going to take away something from Andy, and I'm going to take away the same something from Trevor, alright? At the end of the evening, one has 3 times as much as the other. Right. Now let's take a look. Who's got the most money? Well, Trevor has. He's going to have 3 times as much as Andy, because 49 take away something is going to be a bigger amount than 45 take away the same something. So I reckon Trevor's got 3 times as much as Andy. Therefore, I'm now going to multiply Andy by 3. At the end of the evening, one has 3 times as much left as the other. Okay, so here's my equation set up, and there's my equals ready to go. They both spend equal amounts, blah de blah de blah. At the end of the evening, one has 3 times as much as the other. How much did they spend? Alright, here's my equation. Multiplying out then, 3 45s, I don't know, 135. So 135 take away 3x comes to 49 minus x. I don't like negative x's. You go over there and get added, and you 49 come here, get subtracted. So I've got 135 take away 49 will come to minus x plus 3x. Tidying this bit up, 2x comes to, I'm just looking down here because I've done the sum before, 2x comes to, I haven't done it actually, let's just do it quickly, 135 take away 49, that's 86, therefore x equals 86 divided by 2, 43 pounds. How much did they each spend? They each spent 43 pounds. So what did Andy have left? 45 take away 43, he had 2 pounds left. Let's just make it obvious. And Trevor had 49 take away 43, that's 6 pounds left. And look, Trevor's got 3 times as much as Andy, so we know we got it absolutely right. And I think I'm going to stop there. That's the second part of 6.2, and there's plenty to think about, especially with that previous question with the ratios involved in question 14. So stop there. I'd look at that bit again if I were you. It's tricky.